Hello. Hello everyone, my name is Jade, and today I'm going to talk about trade-off between defense and competition in gregarious juvenile fluted giant clams, Tridecna squamosa. And this paper was accepted by Marine Biology this year. And gregariousness is defined as the tendency of an animal to aggregate with the same species, and is often associated with the benefit like reduced predation risk and increased reproductive success. However, there's also several costs like increased detection by the predators and the increased transmission of parasites and pathogen. This is pathogen. And for example, some of fish they will form large school to prevent the predator. However, if the predator leaves, they will disperse into the smaller group. And also in this kind of species, magic crabs, they only aggregate when they are mating or molting. Molting means change their exoskeleton. This is their exoskeleton. And this behavior in sessile marine animal is also common, just like the mussels. And they may face a greater intensity of the negative effect by aggregation, such as they will face shell deformation, means the damage of their shell, and reduced growth rate. However, they could exclude different species competitors and increase their reproductive success because they cannot move, just like swimming animals. So, not research well as the mussels. The giant clams also display gregarious behavior. In laboratory condition and like wild population, they will find the behavior of gregarious. So in previous study, they suggest that the Tridecna squamosa, the aggregation is a natural behavior. And in Monroe study, how close to the same species is important for giant clams to spawning at the same time. This picture shows the spawning. Spawning means release the eggs. And not like other biovivids, giant clams are known for their ability to photosynthesis through symbiotic zooxanthellae living in their tissue. This is zooxanthellae. So in this study, we want to know if this gregarious behavior in giant clams will negatively affected by aggregation in their growth. And also we want to know if they will be infected by more ectoparasites, which I will introduce later in aggregated situation. And third, we want to know if aggregation provide individual giant clams with greater protection against crushing predators, such as the crabs. So in this experiment, we use 72 juvenile Tridecna squamosa, and we divide it into two groups. One is dispersed, and the other is aggregated. And I need to mention that this squamosa were infected by ectoparasite snail at first. This snail is Toponilla commingi, and it is a common ectoparasite snail in cultural giant clams. And the ectoparasite means the parasites live outside the body, but not inside your body, just like the lice living in human's hair. And before the experiment, these clams were cleaned every 2 weeks. And after 112 days, the shell length and ectoparasite snail count were measured. And in predation test, we use this kind of stone crab, Myomenaper hardwicking, and is known to prey on bivalves and had consumed giant clam in laboratory conditions. And we do the experiment after dusk because this crab is known to active at the night. And in predator-prey interaction, we recorded with infrared camera because I said the experience is after night. And we defined the successful predation of handling time of this kind of crab is from the moment the crab grabs onto the clam to the moment it dislodge or break the clam. And now I will talk our result and discussion together. In growth experiment, we have initial mean shell length for 43.69 millimeter. However, after 112 days, we have we measure the mean shell length and measure the mean percent growth in shell length of two groups. And the blue one is dispersed treatment, and the red one is aggregated treatment. And you can see both the aggregated one, their growth is significantly lower than the dispersed one. And the result is not unexpected because in normal situation we have the giant clam open fully. However, in aggregation situation, they will face the space constriction and mental shedding by their neighbors. So the symbiotic surround them may not can photosynthesis, so led to reduce photosynthesis output and hence their growth rate. And in the parasite experiment, we found that both the frequency of infestation and the account of ectoparasites, the aggregated one has more ectoparasites, and this is 23 out of 27. And the huge difference is not because our efficient cleaning or overlooking in the regular control experiment, because the difference is very large. So we suggest that the high rate of infection is a consequence of reduced distance between hosts in aggregated situations. And we also found that it takes predators more time to handle aggregated shells. First to mention, there's no significant difference in mean search time between two treatments, which means the crab they need the same time for searching the crab as searching the giant clam, but it takes more time for they to handle the aggregated one. And interestingly, crabs were observed to switch their prey more frequently in aggregated treatments, just like humans always cannot decide what to eat tonight because there are so many differences to choice. And we suggest that the complexness in aggregated clams that will obstruct the predator's movement, which means there are crabs cannot go through to the one you want to eat. And also the defensive skills on the valves fill in the gaps with the clam, just like this situation. And in most of animals, protection from predation remains the most important drivers for gregarious behaviors in animals. So I still leave this hypothesis because this is what we think, but the conclusion is here. So our hypothesis hypotheses were testified through the 3 experiments, and we suggest that the gross costs of aggregation are likely a necessary trade-off to ensure the survival during juvenile phase, but at least but not least, though this behavior can protect them in juvenile phase, but this cannot last long. Yeah, and so my presentation is over. Thank you.